Okay, so now let's assume that our developers has created the following few views through the various tools we've created for them. Then a question arises. Who should own the views? How do we go from one to another? How can I know when a view shows up so that I can trigger a network call? Who should update the views when new data comes in? Before answering these questions, we need to take a slight detour to understand a classic design pattern, the MVC. Or in other words, Model View Controller. Model View Controller is essentially a technique for splitting your code into three modules. Model corresponds to your data structure. In our earlier example of stray cat application, this might be your cat class and other data. View represents all of the UI, which we have seen a lot of. And the controller is the module between that is responsible for managing communication between the two. For example, if your cat data changes, it needs to be responsible for conveying this update to the view. Before that, if we want the address displayed in the view to follow a certain format, then we would usually transform the data through the controller before passing it on. We'll soon see that there are many types of controller, and this one we mentioned that controls the view is just one of them. And now let's turn back to all these questions and think about what the answers to these questions should be. So the first one, who should own these views? Since the controller needs to manipulate the views, it naturally can own the views, right? Of course, what each view looks like is still controlled by their own subclasses. It's just that the reference should be held by the controller. We call this type of controller that controls and updates the view a view controller. What we say in our previous demo, the UI view controller, is exactly this thing. And let's skip the middle two and look at the last question first. As we talked about just now, the controller will be responsible for updating the data. So without a doubt, the answer to this question is also the controller. Let's think about the second one now. How do we go from one to another? Actually, the answer is still the controller. Only this time it's different. This time the controller isn't controlling the views, but the view controllers. And we're going to call it the navigation controller. The blue box in this diagram represents a navigation controller. It sort of controls our two view controllers, and here I directly represent them with their corresponding views. And these view controllers, we can name them the child view controllers. When our developers want to jump from one view controller to another, we can provide a method maybe called showed, and let our developers pass in the view controller they want to go. And this way, our navigation controller can automatically add the new view controller's view to our layer, or say the view tree, and we can just maybe display animations for these transitions as well. Or say, when the new view controller performs a dismiss, then we remove these views and show the corresponding animations. Well, does this feel very familiar to a certain data structure? And that's right, this is actually just a stack. We push our new view controllers when showing them and pop them off when dismissing them. We can even use the navigation controller to do more. For instance, we can add properties called title to the view controllers, and in this way we can let the navigation controller automatically add the navigation title. To achieve this feature, our navigation controller is actually also a view controller at the same time. Okay, now let's look at a third question. How should our developers know when a view is presented? Or to put it in another way, how do we notify our developers at different times during the life cycle of a view controller? And the answer again is the controller itself. We can call several fixed methods of UI view controller at different times. So after our developers override them, they can perform different operations at these different moments. So let's take a look at different potential valuable lifecycle stages. First, after events like the show being called or the application starting, we first load the view controller's root view into the memory. And at this time, we can call the view.load method to allow developers to load their required views into our root view, or to perform some other operations like network calls maybe. It should be noted that at this time, rendering has not yet begun, and we cannot accurately know the final position of these views. And after this, we will call the view_will_appear method before the view is added to the screen. Its function is to allow developers to make some modification before the views is officially added, such as like changing its orientation so that we don't have to reconfigure the positions all over again later. If you're developing a landscape game, this method will be very helpful to you. And after this, we can formally add these views to the root view to start the rendering work based on things like the constraints. And at this step, we do not allow our developers to intervene. And after this, because all the views are already in their final positions, if our developers want to make some changes based on their positions, like some complex animation that needs to reference the position information, then here is a good opportunity. Here we can call the view controller's view_is_appearing method. Then we present the interface to our users. And after the presentation is completed, our developers might start playing some animations. So at this time, we can call will_did_appear to allow developers to carry out corresponding operations. There's animation. And with that, the work of presentation is done. And correspondingly, before dismissing the view controller, we can also call different methods to let developers do their final cleanups. For example, if developers no longer need to load a certain resource, they can carry out corresponding operations in the overrides of these methods. And in the past, everything we've seen today was written using the Objective-C language. Nowadays, most new applications have moved to Swift, a new language. You can still use the traditional UI kit, but with some of the latest concepts and new features of the Swift language, we will see a very convenient and fast UI framework, the Swift UI. And we'll see you next week to introduce them to you. Thank you for listening.